So another very common used automation tool set is referred to as Chef. And again, this is a enterprise level type paid for automation tool set. And you know, just like everything else, whether it's Mac and Windows or Linux and Windows or whatever, everyone has their various camps, and some people love Chef and don't really care for Puppet. Some people love Puppet and don't really care for Chef as much. I would certainly advocate that you download and play with both of them, get familiar with both of them. You're likely to run into both of them at various points in your career. They can both be very useful. We'll actually take a look at some of the differences, or some of the main differences between them in a moment, really at the end of this particular subsection for Chef. And you'll find that each of them have various strengths and reasons that you might prefer one over the other. So Chef operates in much the same way that Puppet does, from the respect, or from the perspective of, it does have this idea of a agent or a client, the Chef client, that runs out on the nodes, whether they're physical bare metal servers or whether they're virtual machines, whether they're instances running nodes on the cloud, or even Linux containers. And again, whether they're Cisco or any other device routers or switches, they're going to have this Chef client running on them. And then of course we have this Chef server. Much like with Puppet, we have the Puppet master server, where we have various environment variables, role-based access control, what are called data bags, we'll talk about the terminology here, various attributes and runtime lists and objects that represent the nodes that essentially get compiled from the various recipes and cookbooks. So the idea of Chef in the kitchen, right? So, and we can fully manage this and search this. We can have revision control from a get perspective and have various repositories pushed out or used to push that information out to the Chef server. So taking a look and dissecting some of the terminology, we have this, as I mentioned, the Chef server, and it acts as the central hub for all the configuration data. So it stores what are called the cookbooks, which are the kind of larger macro series configurations, the recipes, or the policies that are applied to the individual nodes, and then metadata that describes each registered node that's being managed by the Chef client. So what is a node? Again, it's any physical, virtual, or cloud-based machine. And by physical, could be a router, could be a switch, could be a bare metal server, could be a storage device. The Chef client, the agent that runs locally on every node and that registers with the Chef server, and it brings it to the expected state. Now, we talked earlier in the Puppet section about resources, and we have them here as well. So Chef resources, so we have these two different types used for grouping managed objects or attributes into one or more corresponding implementations. So we have this resource type, a definition of the managed object, and then the resource provider, how that's implemented with various management tasks on the objects. So again, we have this idea of a cookbook and then the recipe. So the cookbook is this fundamental unit of configuration and policy distribution. So each cookbook defines a scenario, and then all the components that are required to essentially support that scenario. Then we have the recipes within the cookbooks, and the recipes are mostly a configuration of the various resources, defined usage patterns like resource name, key value or attribute value pairs, and the actions, as well as helper code can be added around this using the Ruby language, which Ruby is a programming language if you're unaware. We've talked a little bit about it earlier when needed. Chef is written and authored using Ruby, which is a very beautiful, easy to use language. Just like Python, I would say Ruby is actually a little more so easy to use. And essentially the recipe must be stored in a cookbook, which kind of makes sense from that analogy perspective. And it may use the results of a search query and read the contents of what's called a data bag as part of its recipe or as part of its configuration attributes. And it may have dependencies on other recipes. So some recipes can say this recipe essentially can run and create the desired configuration, but only if something else has already been issued or run. So they can have these dependencies, other things that must be essentially run first. That way we don't have to bundle everything into a single recipe. We can have multiple recipes, keep them modular, keep them objective, and very reusable. So this must be added to the runtime list before it can be used by a Chef client, and it's always executed in the same order as it's listed in the run list. So the Chef client will only run a recipe when it's asked. So continuing on with the terminology, we have this piece called Ohai. And Ohai is a tool used to detect the various attributes that are available on a given node and provide these attributes to the Chef client at the beginning, at the start of the Chef agent or Chef client. So this provides the attributes to the Chef client, such as platform details, kernel data, host names, fully qualified domain names, IP, on and on. And then we have this concept of a workstation. And this is really a computer that's configured to run what's called knife, which in a kitchen would be something that we're going to use to slice up the various components before we put them into the recipe, right? So we're going to use this to synchronize with the Chef repository and interact with a single Chef server. So the workstation is located somewhere which most users will do their work, including developing the cookbooks and the recipes, authored using Ruby, keeping the Chef repository synchronized with various version control, source control, using the knife to upload the items, to cut up and upload them to the Chef repository, or from the Chef repository, I should say, sorry, to the server, and then configuring this organizational policy. So defining roles, the various environments that assure that the critical data, where it's stored in the data bags. And then they interact with these nodes, so essentially where the Chef client is run, when required, such as performing, for instance, a bootstrap operation. So let's take a look at a workflow. Here we have, for instance, the client.ruby file that has been essentially generated as Ohai has captured the various components, the information about the node that it runs on, provided to the Chef client, where it gets the configuration data from Ohai, authenticates to the Chef server, and then as it authenticates, it gets the build or rebuild the node object. It expands the run list from essentially the cookbook and recipe. It synchronizes cookbooks. It can deal with any reset of the node or attributes, and it can essentially take the compiled resource collection and essentially converge the node, or take and apply this information and then update the node object, the process handlers, and stop and then wait for the next run where reporting is run, and essentially success or fault management, where we find out, was there a success, store that to the log file, send out emails, and make sure that everything is in compliancy unless it needs to be run again. Now currently in the Cisco device plugin, email is not able to be sent outside the container, so support is coming for that. As an example of, for instance, the configuration of a Cisco Nexus 7K device, we have, of course, some comments for the cookbook name and the recipe, and then essentially a require, so what subcomponents or what dependencies we're requiring, what the device host name is, and then how we're connecting to the device with username, password, and applying configuration to an interface ETH19. Basically setting the description and setting switch port enabled. So again, this is also packaged as a virtual service in a Linux container as an OVA. The OVA registers, again, the CLI extensions, config, show, exec, clear, and debug, and it does rely on the 1PK VTY service set, as we mentioned before. So here, for instance, we can see on the Chef server, we are drilling down into some of our devices, into our Nexus, in this case, our Nexus 7K, and looking at the various hardware, host name, and images has actually been expanded, and looking at the subcomponents of the Kickstart image, the 1PK library, and various packages that are running. And again, this is supported on the 9K now as well. So another lot of good references, kind of general overview, what is Chef, basic hands-on tutorial, the resource types that can be used, and again, the Chef user guide and troubleshooting guide should now be published as the time of this writing. So some of the main differences between Puppet and Chef. Puppet uses domain-specific language in its configuration files, so we took a brief look at that, whereas Chef uses Ruby or Ruby-like syntax as it was written in Ruby. So Puppet requests, these have dependency declarations and they satisfy them when the declarations are made. Chef operates essentially in the order in which the resources appear in a cookbook. So a little bit different in how things are applied between the two. Puppet Enterprise runs on your machines, as does the private Chef. Hosted Chef can be a cloud-based or SaaS-based solution, right? Software as a service. Chef does more processing on the agent side. Puppet does more processing on the Puppet master or server side. Chef is typically targeted more towards the development side of the house or DevOps, and Puppet is typically run more by sysadmin side, or targeted that way, and that's typically where you find those camps. So developers tend to prefer Chef, certainly the ones that I know do, and sysadmins, Linux admins, network admins, they tend to prefer Puppet. And certainly not the last one that we have. We mentioned there's a few others, SaltStack, CF Engine, others that are even emerging. But one of the most, or I should say the third really most popular one is Ansible. Now Ansible is quite different than Puppet and Chef in the sense that it does not have this context of an agent, right? So it is agentless. It essentially uses SSH to push configuration into the devices, into the nodes. It is based on Python, so if you're more familiar with Python, you may prefer Ansible. And it's extensible, so you can really use it for just about anything that you can write the configuration for. So you can see kind of from a high level, we have a change management database, public or private cloud. Users can create Ansible playbooks, which would be comparable to, for instance, Chef cookbooks or Puppet configuration files, DSL files. And these playbooks then run through the Ansible orchestration engine, which maintains inventory, various module components, various plugins, and API interactions. And then these push these out via SSH to hosts and to network devices. So some of the terminology, we have our hosts, groups, and inventory. So our hosts are essentially the remote machines that Ansible is managing, but again, there is no agent running on these, which does make it fairly attractive in the sense that we can use it for almost anything that we can come up with a use case for and create a Python module configuration if it doesn't already exist. Groups are essentially groups of hosts that a pool can be conveniently targeted and managed all together as one, or apply the same configuration file, or at least base config file to. And then inventory is essentially a file that describes what those hosts and groups are. So very, very simple, so we have a simple host, then we have a simple group with square brackets and our fully qualified domain names. We could have switches, and again, they can be using IP addresses and even substandard, or I shouldn't say substandard, non-standard ports. Continuing with the terminology, we have Ansible modules. So these are units of work that essentially Ansible ships out to the remote machine. These can be executables. Some of these modules could be pre-installed, and you can even create your own with any language as long as it can be an executable. We have Ansible tasks. So these are a combination of various modules with their arguments applied and the description name. And then we have plays. So this is a mapping of the host or group of hosts to the tasks that need to have executed the modules. So then we have playbooks, which are a collection of plays, which Ansible then orchestrates and allows configuration, administration, and deployment to the systems. Now this is written in a text file language called YAML. So YAML is really a backronym. YAML doesn't really stand for, but kind of originally was just created, and then someone later went and created a backronym, meaning that they created the acronym after that had already been, or the definition for the acronym after the acronym had already been created. But YAML, a lot of people refer to YAML ain't markup language. So in other words, it's not necessarily a markup language like XML or HTML, some sort of markup language where you can mark it up however you want. So it does provide a human-friendly way to store serialized data. And there is a construct or a framework around it that does have to be followed. But here, and there's lots of good information out there, Wikipedia has, but also plenty of other places have lots of good information on how to create YAML files, or how they are structured, how the data, the syntax inside has to be structured. Even though what is inside is up to you, so it kind of is a markup language, but it's also referred to as ain't or not a markup language. At any rate, you can, and in fact, actually one of the best places to learn about YAML is to go to the Ansible website and look at some sample files and look at their description and kind of how-to guides. So they provide a lot of great hands-on labs and understanding of how to use not only Ansible, but also YAML for the text files. And YAML can be used and is used far outside of just Ansible. It's not anything that's specific to Ansible. It's just a data serialization format. So for instance, with NXOS, we use containers on NXOS to open up a SSH connection where Ansible can connect. We can create custom Python modules using NXAPI, and we'll talk about NXAPI in the next module. For instance, here to create and delete VLANs, and we could write playbooks to use custom modules to then, for instance, configure various VLANs. So for instance, here we see on the Ubuntu Linux VM that's just running the Ansible server that has Ansible installed. In a playbooks directory, we will run an Ansible playbook based on a YAML file, which just happened to be named create_vlan.yaml. And it will go out and execute the plays in that playbook, gather facts, SSH in, create the tasks, and then recap what happened in the play. And then on the switch, we can see if VLANs were created. So again, we'll take a look at this a little bit more in the hands-on section. But for now, just keep in mind that Ansible can be used really in almost any various way that you want, and we don't have to first have anything installed on the device. So any device, whether it's a Cisco router, switch, or anything else, Ansible can be used on as long as the device supports and has enabled SSH. And of course, we have to have a valid username and password. So some general references on Ansible. An introduction to Ansible, various modules, how the YAML syntax is structured and the basics of that, and then there are a lot of great videos out there at ansible.com/resources to get you started. So I highly encourage you to go out and check out all three, Puppet, Chef, and Ansible, and play with them all and essentially figure out which you like most.